So over in your main menu for your course, I've rearranged this a little bit. So here's our laboratories. So right now we have our lab documents. So inside the lab documents, this is where the lab procedures are going to be at, and then of course the actual labs themselves. And then I have one called level control, which is, and this is where your lab chapter quizzes are at now. So you don't have to take pictures of those and send those in. And I thought I explained that last class, but somebody did send that in. So whoever sent that in, you need to go back and redo it here because this is where it's going to be graded. So now the actual the actual chapter quizzes that's at the end of each lab, they are actually posted. So this is the one for proximity sensors, and that was due within 7 days after we finished that lab. And I know somebody did submit. They did send it by. They did scan it, or they did take a picture of it and send it, and that would be really hard for me, guys. Here, this is going to grade this for me. So, by the way, all these are new and they're still kind of in draft form. So, if you have any problems, if I didn't spell a word right or something like that, or don't make sense, you need to let me know. But these should be copied or printed in directly after that. So, what we're going to be doing now is, and y'all can write this down and come back and fill it in later. But what we're going to be doing, okay. This, guys, is we don't have to have a meter. All these uh, so now when you go in here to level controls, and then you click on that, it should come up view assessment. What it's going to do is it's going to come up with questions where instead of having to write this stuff down and taking a picture of it and send it to me, you can either record this. So the way this is let up, this is section A. So the first question we're going to have to answer is in section A, step 9. So what you can do is you don't have to try to do this while it's there. It's just that you can, when we get to section A9, you write your answer down, right? Maybe record it just like this, and then when we get through, you can come on here and do what? You can type your answers in. So what I've done is every question that requires yes, no, or answers, I've done it here. It'll be a lot easier for me too, and even the actual chapter questions are also in here. So, ooh, I don't see those. I might have to actually do that, guys. What is another name for control? Yeah, these are here. What's that? What I didn't do? Oh yeah. So this is the lab questions. I'm gonna make this really really big. This is actually where the actual lab questions start, right here. So these are lab questions. I'm gonna make this really really big. So actually, where those questions at the end of the lab that y'all been writing out and then printing them. So everything that deals with the lab is going to be inside here. It'll be a lot easier on me. It'll be a lot easier on you. You won't have to worry about did you do this, did you not do that. So this is the way we're going to do them from now on. By the way, all these were all typed in. I had to type every one of these in, so there still might be some few mistakes in here. So if y'all see anything that's not worded correctly or the same as it is in the actual labs themselves, then y'all need to let me know. So what we're going to do now is I've put these are all three labs that we're probably going to get through today, because this one all we got to do is just swap the direction on one of our sensors. So we'll be able to do these real fast. And then this one is a design. This one has a design project in. But what I've done is I've done the design. We'll look at it and see if it's going to work okay. So y'all understand that? Got any questions? So here's the quizzes. So right now the quizzes you should have the lab quizzes you should have got through with is proximity sensors. There's not a lab quiz on potentiometers. So y'all understand that, what this is going to do. So everybody should have done this one by now. because we finished lab 3. So y'all need to go out there and take care of this probably today for me. Okay? And I'll try to give y'all some. So what we're doing is we're looking at let's go here and close it and bring up lab documents. We're going into our level control labs. And of course these are between PowerPoints and then of course lectures. These are basically your textbook. So, and they're available to you free. So it's got these big discussion sections on here. We've already labeled this, and a lot of the stuff a lot of the terms on the test was actually out of these documents. I had an instructor when I was in college, and he gave out handouts all the time, and he would never that he never would lecture on. But when you got to the test, guess what? There was questions on the test about every handout that professor gave during the test. So you got in the habit of going out and reading all those handouts. So here we're going to deal with 3 types of level control systems. We're going to deal with what they call a charging system. So basically this is going to be, it's also called a pump control. This is used where when we get down below a certain level, it's going to turn the pump on and fill the tank back up. And right now we're not looking at sensors on detecting when it's full. We're just going to turn the pump on. And this is going to be called charging system, and it's also called a pump control. And what it's going to use is it's going to use a normally closed level switch that's going to be mounted at the bottom of the tank. So when the liquid gets down to the bottom, then the switch will close and turn on the pump and fill it back up. This is where we get into what we refer to as an interface device, and this is a really good example where we've got a solid state limit switch or solid state current that's got a maximum load current of 5 milliamps, and I'm trying to pull in a motor starter that requires 30 milliamps. Well, we cannot do that with a lot of, especially solid state sensors. Solid state sensors are not designed to run heavy loads. So what we usually do is we take the solid state sensor and then we energize a control relay, and then not only does that, so just about all your solid state sensors are everyone that I've ever seen has either one contact, has one normally open contact, or it has a double pole. It has a single pole double throw, and y'all understand those terms, right? So that gives us, we can either use it normally open or normally closed or vice versa. So that means, and I need 10 contacts. Well, what we need to do, of course, is we need to take that and run it into a control relay, and then the control relay can bring in our other devices. Now, a control relay is a relay whose contacts are not, they're only in the control circuit. There's no control relay contacts in our power circuit. So in motor controls, we learned that just about all motor control systems are made up of 2 units. They're made of a control system and then a power system, right? The power system is basically where you have to start putting all your PPE, and that's where these guys would be located. So the actual motor starter itself would probably be over in the power section. And then we would run a wire from our control section over to the power cabinet to bring in the motor starter. So what they're referring to it here is they're calling these devices as interface devices. So these are the guys basically this is going to be our control relay that's going to basically whose contacts are in the control circuit. This is our liquid level switch that we're going to be using in this experiment. It is a reed switch. So basically what we have is we have a reed switch. That's on. This is not exactly the one we got. So the one that we have looks like this. So that's not the one we got, but it looks like this. So it's got the actual mechanical float. that moves up and down. It's mounted out here. And then over here it's got a lever right here. And then the arm comes out on this side over here. And then this has got a permanent magnet mounted inside of it. And down here it's got a reed switch. Now we can mount this two different ways. We can mount it so here this would be when the level goes down, this would open, and when the level goes up, it would close. So this would be a normally closed, right? No, it wouldn't. This would be a normally open because it would sit like this until the level comes up. And then what we do to change this to a normally open is we just flip it around. And maybe it'll make sense when I bring up my camera and show you what we're doing. So this is what they're telling us here on the lab. It's telling us that we just mount it upside down. So we're not going to take the switch off. We're just going to change the way we mount the switch to get a normally open or normally closed. So to get a normally open, we would mount the panel right. So let me bring up my camera so this makes sense. Not that camera, Rich. This camera here. So what I've got is I've got the components up here for our first circuit. And this is our liquid level switch. We've actually got two. This one we can change from a normally open to a normally closed or vice versa by snapping off this little plastic ring right here, or washer, and which would be this guy. And then what we would do is we would just take it off and turn it around. So right now I have it set up to be normally open with the panel mounted upside down. So here's the liquid level switch we're going to start off doing. And you probably can't see it, but here's the permanent magnet in here, and then the reed switch is here. So this would be normally closed. So right now, without any liquids or anything, it would be in this situation right here. And to make it de-energized, then I just move this up. So notice we got it mounted upside down. So this one I can't swap around, but it can be changed depending on which way you mount it. So this can be used as a normally open or normally closed. Here, since it's mounted real well, all we do if we need a normally closed is we just mount the panel upside down. Are we okay? So these are all the components we're going to use for our first circuit. So this is actually the first circuit that we're going to wire up. So we're going to have a normally closed float switch. So I have my panel mounted upside down. We have a selector switch, which we're going to move between hand and auto. Ours is not called hand, by the way. Ours is called manual. So in auto mode, auto mode, we would close this contact right here. And now if the tank is discharged, this is mounted at the bottom of the tank. So our sensor would be here if it's a charging system. Sensor would be here. So what happens is we fill the tank up, and then we'll come back, and when it drops down, it'll start the motor and fill the tank back up, and drops down, start the motor. So this is called a sump control. I mean, it's called a charging system. It's also called a pump control, because here we're controlling the pump, what's actually filling the tank up. So if the level is too low, what it'll do, and of course here we would have problems if this was a solid state float switch, because it's a load current. Its maximum load current would not be able to bring in the motor starter. So what we would do is we would add a control relay. So the control relay contacts, which is probably rated in amps, we have enough current to pull in the control relay, close this contact, and pull in the motor starter. And I'm not going to hook up the motor, by the way. All I'm going to hook up is the motor starter. So this is the first circuit we're going to wire. So I have my my float switch, I have it mounted as a normally closed. I have my selector switch. I have a push button station. So I have my power source, my disconnect. I have my transformer 208 here. Divide by 4 gives us about 114 volts right there. Here's my push button we're going to be using. We'll be using the start button, which is 3 and 4. Then I go over to my selector switch. The manual on the selector switch is 5 and 6. And then the auto is 7 and 8. It's got a center off position, by the way. So if we put it in the center off position, we shouldn't be able to run it in manual, and it shouldn't run in auto. This is my level switch. We're going to be using this guy right here. It's between 1 and 2. Here's my control relay. The control relay, the coil is 14 and 13. I'm sorry. Yeah, 14 and 13. This is my coil. And then we'll be using contacts. This is a 3-pole double throw relay. So we're going to be using 9 and 5. We need a normally open contact. This is my motor starter. We'll only be using the coil on this. We won't be wiring up the motor. And we're going to be using, on our input, we're going to be using 10. And then our overload on the other load is 9. And probably you can't, hopefully, like I said, this camera, I need to probably buy me a new camera. Because it don't like to focus real well, but we'll see. I think it does. It's going to be good enough for this. I don't know. I've had this. This is probably the longest camera, the oldest camera I have. So I don't even know if I got the documents on it or not, and it don't have it on there. It's not the pixel. It's the autofocus feature is not working. See, so it does okay over here. Most of these cameras are supposed to autofocus, so it looks like the autofocus feature on it is not working exactly right. So if I could get it real close, it would probably focus okay. But of course, everybody knows what a pixel is, right? So yeah. So this is the diagram. So y'all can't really see the numbers, but I'll call these out for y'all. Yeah, they show up okay. 5 and 6. So we're going to use 5 and 6 up here, and then we'll go over to our normally open push button, which would be 3 and 4, and then 13 and 14 is our control relay. This guy is manual. This is 7 and 8, 1 and 2. And down here, this is going to be 9 and 5, and 10 and 9. So I'm going to have to take my, well, I can see, guys. I can see this when I'm trying to wire this up. So what we'll do first is, what I like to do is I like to run the L2 side first. Then I like to run the L1 side first. And then we'll fill in the in-betweens. We're going to questions about the college. I'm going to have to cut all this out, so I should have paused my lecture. But so what we'll do is we'll wire up, we're going to wire up the L1 side. I'm sorry, we're going to wire up the L2 side first. If my camera switches over. So we'll take L2 first. So I'll come up here and go for my fuse side, which is L1. I'm going to bring this over to 14 on my control relay. And then from 14 on my control relay, I can't use that one. For 14 on my control relay, I'm going to go to 9 on my motor starter. And then, of course, that means we've got that L2 side works. It's only supposed to go 2 places. My fuse side, it should go to 5 on my selector switch. It should also jump to 7 on my selector switch. And then it should go to 9 on my control relay. Okay, that's the L2 side. So what we're going to do now, so I've got it going, I've got my fuse going to my fuse side. I have it going to 5, and I have it going to 7, and then I have it going to 9. My L2 side, which is this guy, L2, I have it going to 14, and I have it going to 9. So we can't have a short circuit. So I need a jumper between 6 on my selector switch to 3 on my push button. I need it going from 4 to 2 on my float switch. Might have to move this down, guys. And then I've also got it going to 13 on my control relay. Okay, so I've got that side. I need 8 to 1 on my selector switch. I should use a short one here, but oh, that's not one, Rich. That's one. Oops. These trainers have screws in them. I don't know if that's going to work or not. Oh, I see my problem. Okay, there we go. And then 5. Oops. and 5 to 10. 10. Okay, so we'll check this out and see if it's going to work. We know we don't have a short circuit. So we should manually, I should be able to push my start button, and the motor starter should come in and out. Then on auto, we should be able to control it with our limits, with our float switch. Okay, so what are we supposed to start off first? Anybody see the procedures? Let me read them to you. In fact, let me bring them up. So it says put the selector switch in hand, which will be manual, and press the start button. Can y'all hear that? Yes? Okay. So number 9 says place the selector switch in the hand position. Did the motor start? So that's A-9 right there. So y'all need an answer there. Press and hold the push button down. The motor should have started. If not, ask the instructor if you can use a digital meter. So ours worked okay right there. Nobody said I didn't pull off my tag. I got a safety violation. Then it says place the selector switch in the auto position. Okay, so I placed it in auto position. Did the motor start? So I'm going to take it off, see if y'all can hear it. So the motor started. So this is A-11. Yeah, so here's the hand position. So the motor starter's out. So the hand position, I'm supposed to be able to manually run the pump. The other one, the pump is going to be controlled by the level switch. So right now I've got it in hand, and I come over here and press my manual override or my start button. So now I'm controlling this manually. Hear that, James Roy? Okay, so this is auto. So auto, it came in instantly, which is telling me my tank is empty. So we started off with our tank empty, right? This is a charging system. Okay. So I'm sorry. So this would be tank full. So our tank started off full. And then when it gets empty, because this is a charging system, so I said that wrong. When the tank gets empty, the liquid level switch drops down and turns the pump back on, fills the tank back up. When the tank gets full, you'll see this. So here, I'm manually doing this, but this would be controlled by my liquid level switch. Of course, I don't have a level switch. If I come over here and put it in manual, this guy right here makes no difference. Nothing happens because I'm controlling it manually, right? If I put it over here, it says place the switch in auto. Did the motor start? Yes. Simulate the level switch detecting a rise in the level of the activated switch. So here comes my water up at the top. We're charging it, and then it gets up to the top of the tank. Then this does what? Turns it off, right? Everybody okay? Yeah. So I think I told y'all wrong. So the level switch would actually be at the top of the tank. I think I told y'all the bottom when I was wrong. I was on that. So the level switch would actually be at the top of the tank. Simulate the level. So that was 11. So that was A12. It says simulate the level switch detecting a rise in the level by activating the level switch. Did the motor stop? Okay, it stopped. And of course, if it drops down, it'll start. Redraw the circuit. 6, adding a red lamp in the on selector switch. Also add a green lamp on anytime the selector switch is in the auto position. No lamp should be on when the selector switch is off. Okay, so we got the center position. So the center position, the whole system is off. So on this one, we wouldn't need that. We wouldn't need that master start stop. All I can do is just turn the whole system off with my selector switch. So here I can't turn the motor on with this. Here I can't turn the motor on that. If I move it to manual, we can control it here. If I move it to auto, then it would be controlled there. Are we okay? Okay, sorry. When we're in the off position, the system is off, right? Does that make sense? So notice I can't control the motor with my liquid level, and I can't control the motor with my manual override. If I put it in manual, the liquid level switch has absolutely no function. So I can come up here, I can turn on my pump motor with my push button. And then I could turn it off with my push button. Somebody needs to mute their mic. If I put it in auto position, then now we moved over to the level. So my pump is running, right? The relay's energized. Y'all can't see it, but I can see the relay's energized. This is the motor starter. When the level gets up too high, we turn the pump off. So this is called a pump control, and it's also called a charging control. It's got two names. Are we okay? So we should have two answers here. We should have one for no, we should have three. Number 9, so A-9. When you put it in a hand position, did the motor start? Wait, no, let's do that. So here's the hand position. Did the motor start? No. Yeah. Press and hold the button. The motor should have started. If not, ask the instructor if you can use the digital multimeter to test. So I don't know if I've got a 10 on there too. So y'all put A10. I might have put that on there to let y'all see that. So the motor starts, the motor don't start. So put A10 on there and put yes for me, because that might be on the quiz. While I was doing this, guys, I think I added another one right there. I'm not sure. Then in 11, A11, that would be yes. A12 would be no, right? And then we need to turn our system off. Okay, before we turn our system off, does anybody else need to see anything? A10's, what do you mean? I didn't know. I said I might have put an A10 in there. I didn't remember. Okay. I'll have to do that for. Okay. I know I did that somewhere, but I couldn't remember where it was. Okay, guys, 15-minute break while I re-gear.